substitution problem had a little bit of a different twist to it. Typically, we would go with letting u equal to whatever is like the binomial. See, this is the same thing as to the 1/2 power, right? But if we let u equal to x plus 1, then du would just equal to dx, right? So that doesn't help me as far as getting rid of this term right here, this x squared term right here, except for one thing. I can turn this around right here, and if u is equal to x plus 1, then x is equal to u minus 1. Are y'all with me? All right. So, this problem now becomes, instead of x being squared, I have u minus 1 being squared. And then it's times u to the 1/2 power. Now, here I'm not able to distribute into here. But in this case right here, I can square this binomial out, and I can distribute the u to the 1/2 into that parenthesis to get where I want to be. So let's square it. So I've got u squared minus 2u plus 1 times u to the 1/2 . Are we still okay here? And honestly, this problem right here does not occur very often in AP Calculus. Usually once you do a u substitution, you don't have to go back and take another variable in there somewhere else and do it. But there is the occasion that it will. So when you get to a problem like that, it's going to be a little bit tricky to go about it because you're not used to thinking in those terms. All right, u squared times u to the 1/2 would be u to the 5/2. 2u times u to the 1/2 would be u to the 3/2. And then plus u to the 1/2 du. We still good? Okay, so this is 2/7 u to the 7/2 minus 2 times, this would be 5/2, so 2/5 u to the 5/2, and then plus 2/3 u to the 3/2, and then plus my constant. Are we still good? Okay. So we can clean up, I'm going to combine two things. I'm going to clean up this right here, and in the same step, I'm going to let my u value be x plus 1. So I have 2/7 times x plus 1 to the 7/2 minus 4/5 x plus 1 to the 5/2 plus 2/3 x plus 1 to the 3/2 plus my constant. And I'm done. All right. One last example. Or has everybody got this copied down? Okay. go with the sine of the square root of x over the square root of x. Now, typically, if I have multiple trig functions in a problem, I'm going to see what trig function is the derivative of another trig function. But in this case, I only have one trig function. So I'm not going to let u equal to the sine of the square root of x. Let me show you why. If I say let's let u equal to the sine of the square root of x, then du all of a sudden becomes cosine of the square root of x, and then times 1 over 2 square roots of x. But I don't have a cosine in this problem anywhere, right? So because that cosine's nowhere in the problem and I just can't drum it up, I realize that I've started off with the wrong thing. That's again what I told you. If you don't know where to start with something. Now, while I don't have this in the problem, I'm fine with sine because I know what the antiderivative of sine is. It's negative cosine. So that's not a problem dealing with sine. I need to deal with this square root of x here. So if u is the square root of x, then du is 1 over 2 square roots of x dx. So I now have the antiderivative of sine of u. Now, I'm not going to put sine of u over u. Even though the square root of x is u, I'm not going to do that because I also have this square root of x to deal with right here. So the square root of x that's in the denominator is going to be taken care of when I go back and substitute back in. So I have right here, this is the same thing as the sine of the square root of x times 1 over the square root of x dx. So really all I'm missing is this 2 here. So what I'm going to do here is I'm going to let 2 times du equal 1 over the square root of x dx. So now I have the sine of u times 2 du. So now I'm going to pull out the 2 here, so it's 2 times the sine integral of the sine of u du. And what did we say earlier the antiderivative of sine of u is? Be careful. Negative cosine, yeah. So this becomes negative 2 times the cosine of u plus c, which becomes negative 2 times the cosine of the square root of x plus c. And I'm done. So again, a lot of these problems are going to take a lot of work. The problems I'm going to assign to you, the first few problems are going to be, they're going to tell you what that u value is to use. And you're going to use what they tell you to let u be. But then after you work a few of those problems, then they're going to give you some examples. And you're going to have to just choose, hey, what do I want u to be? And go from there. So